Hello everyone. In this video we're going to be discussing section 10.4 of your textbook, Use Square Roots to Solve Quadratic Equations, which begins on page 652. So what it means to solve a quadratic equation is to find your roots, or your zeros, or your x-intercepts, those x values. Right, where your lovely graph crosses the x-axis. So in this section we're going to be looking at a couple of different ways to solve for x using the square root. Alright, so what we are going to do, as you can kind of see how they write it out, I could have anything in the form ax squared plus c equals 0. And one thing to note here that your b term, your bx, in this case b equals 0. So I actually am not going to see that x term. So I'm going to be able to, subtract whatever c is, move it to the other side, and then divide by whatever a is. Alright, and I'm going to get this x squared equals d equation, and then I'll be able to take the square root. So depending on the actual value of d, we are going to be stumbling here into one of these three situations. So if d is greater than 0, so it is positive, I am going to have two solutions. So when I take the square root of something squared, this is something that we cover very thoroughly in Algebra 2. When I take the square root of something squared, I want to include a plus or minus, because if I have x squared equals 4, well, it could have been a positive 2 squared, which equals 4, or it could have been a negative 2 squared. Negative 2 times negative 2 is still a positive 4. So I have to account for both of those possible solutions. In addition, if d equals 0, so let's say the other side of that equation equals 0, when you take the square root, there's only one way to take square root of 0, and that's going to result with x equals 0. That is true for your parent function of just y equals x squared. Since b is 0 and c is 0, that means that my only x-intercept is at x equals 0, and that's also going to happen to be my vertex for my parent function. On to our third possibility here. Let's go ahead and say d is negative. Well, you could test it out and take the square root of just any low number, negative 1, or you could take the square root of negative 100. That is going to result in no solution. We can never take the square root of a negative number. So I'm going to point us over to the left side of your page. Recall that in this course, when I'm talking about solutions, when I'm talking about those x-intercepts, where the graph crosses the x-axis, we're going to be referring to real numbers. So you're actually going to see it. So if this graph, let's go ahead and draw a little parabola here. Let's go ahead and say this graph is up here. It doesn't cross this x-axis anywhere. So that means I'm not going to have a solution. Alright, in Algebra 2 we're going to get to actually finding these different values and being able to take a square root of a negative number, but not in this course. So let's go ahead and look at an example. Our whole goal here is do what you can, work from the outside in, and isolate that x squared and then take the square root. So in step 1, of course, write out the original equation and then divide by 2 on both sides, moving that 2 over. And then since this d is positive, so since 4 is greater than 0, I need to make sure that I have a plus or minus here. Alright, so the square root of something squared, I need to include that plus or minus. And when I actually take the square root of 4, I get 2. So my solution there is negative 2 and positive 2. So if I were to look at my graph, I'd have a negative 2 and a positive 2, and then I know it opens up since that a is positive. Alright, so at the very bare minimum, this is a super rough sketch, but I've got it. Alright, another way you can do it is to solve for 0 and then factor. Alright, so as you can see, they went ahead and they subtracted 8 from both sides in this step. They then found that each term was divisible by 2, so they factored out a 2. And then this x squared minus 4 is the difference of squares, so it factors into x minus 2 times x plus 2. And using the zero product property, this one gives you a positive 2, and this one gives you a negative 2. Alright, that's just another way to go about it. And here is example 1b. So I have m squared minus 18 equals negative 18. We yet again are going to want to isolate that m squared, so we add 18 to both sides. And when I add 18 to the right side, it cancels out as well. So I'm now taking a square root of a 0. So that's going to result in one solution, m equals 0. So what that means for my graph is that directly at 0, 0, that is going to be the vertex and the only x-intercept of my parabola. Alright, so the solution for that is 0. We love solutions of 0. Okay, part C here, b squared plus 12 equals 5. Subtract 12 from both sides, and we get negative. So when I try to type in the square root of a negative number, it's going to say DOMERR, domain error, or it'll just pop up error, or something like that. So negative real numbers do not have real square roots, so there is no solution. So what you would give me is no solution. You would write that out. Alright, simplifying square roots. So this is something that we are going to go over very, very thoroughly in Algebra 2. So it's important that you get this general concept down so that when we talk about it next year, you know that I am not speaking a complete foreign language here. So in cases where you need to take the square root of a fraction whose numerator and denominator are perfect squares, so a list of perfect squares, 0 is 0 squared, 1 is 1 squared, 4 is 2 squared, 9, 16, 25, 36. Hopefully you guys know these. Alright, you should definitely be able to, do up to, I would say, typically 12 squared, 144 in your head. You might have some other ones memorized or be able to easily do something like 20 squared, so, which is 400. Okay, so in the case where we have a fraction with those perfect squares, the radical can be written as a fraction. So, for example, the square root of 16 divided by 25 can also be written as 4/5 because 4/5 squared is 16 25ths. Alright, so when we have the square root of 16 over 25, that's also equivalent to the square root of 16 over the square root of 25. So you can break it apart into those two pieces and get 4/5. Alright, so if we can break it down, we absolutely want to break it down to get those smaller numbers. Alright, so example 2 here. We're going to want to divide 4z squared by 4, which means I'm going to divide 9 by 4 as well. Alright, so that gives me 9/4. And when I take the square root, I am going to get 2, since it is positive, 2 solutions, so I'm going to have plus or minus square root of 9/4, which becomes plus or minus 3/2. Alright, so the solutions are 3/2 and negative 3/2, so that means here's 1, here's negative 1, here's negative 2, here's positive 2, right here at positive 1.5, and negative 1.5, that is where my graph crosses the x-axis. Alright, so approximating square roots. Sometimes we aren't going to have solutions that come out perfectly evenly. That is not life. It's just not realistic. So we've got to be prepared. So in the cases where d in the equation x squared equals d is not a perfect square or a fraction created with perfect squares in the numerator and the denominator, you need to approximate the square root. And how we're going to do that is simply using our calculator. Alright, so solve 3x squared minus 11 equals 7. It's just a, two-step equation with a square root on the end for your third step. So they want us to round to the nearest hundredth. That is 2 decimal places. So I write out my original equation. I add 11 to both sides. Dividing by 3, I get 6. And I know that 6 is not a perfect square, but it is positive. So this is exact. This is what I would call exact. In geometry and in Algebra 2, I sometimes will ask you for exact solutions, and other times I will actually ask you to round, like these directions say. So, in the case where you have to round, you take the square root of 6, and you get about 2.45. That is why they change this symbol from equal to about, or approximately, alright, because it's no longer exact. You have rounded. Alright, so your solutions are negative 2.45 and positive 2.45. Here's a couple of guided practice. Please feel free to, pause the video, go a couple of seconds, and see if you get the same solutions. Alright, here in example 4, we're going to be adding on about one more step. So they do say round, so I have a feeling like I'm definitely going to need my calculator here in the end to approximate. Alright, so the first thing I want to do is write out my equation. And then that 6 is on the outside. So since that's not right in there with the x, I want to go ahead and divide each side by that 6 first, working from the inside out. If there was an additional, like plus 1 on the outside, I would then start with subtracting 1. But here, I'm going to go ahead and divide each side by 6, and that's how we get 7. And then I want to take the square root of both sides, because we're working from the inside out. So when I do take the square root, keeping in mind that 7 is positive, I need to include that plus or minus. And then my last step here, isolating x, I need to add 4 to both sides. Alright, so all of the work shown in each step, divide by 6, then I take the square root and include the plus or minus, and then I add 4. Alright, one very interesting and important notation thing is that I don't write plus or minus the square root of 7 plus 4. The reason why this 4 is out here in front is because Billy Bob Joe and, Susie Ann, they have awful handwriting. So sometimes I can't tell where this house ends. So I might accidentally add that 4, which I shouldn't do, because this is not equal to the square root of 11. Right? You can type that into your calculator and verify that if you don't think I'm telling the truth, but that's just not legal math here. I can't, all of a sudden move this under the house. Alright? The roof ended here, so I need to make sure to avoid any handwriting error and put that 4 out here in front. Alright, which is what they do. So the solutions. Separating the two solutions, I've got 4 plus the square root of 7 and 4 minus the square root of 7, because that plus or minus goes with that square root of 7. So when I type those into my calculator separately, I get approximately 6.65 and approximately 1.35. Alright, and example 4, the check for this is to go ahead and substitute in those values and see if you do get 0. In another way that you could do it, which they're telling you, is solve for 0 instead. Alright, so if I have my original equation, that's 6 times x minus 4 squared equals 42, when I substitute in my approximate x values, I should come out to a true statement. So it should be, it's not going to be exact because we rounded. So I'm going to get 42 equals 42, approximately. Alright, it's going to be just a little bit off. But if I solve for 0 like they did here, and then I graph it in the graphing calculator or on Desmos.com, you would see that I'm hitting the x-axis at approximately 1.3 and 6.6. Alright, so those are a couple ways to double check yourself. So, example 5, sports event. During an ice hockey game, a remote-controlled blimp flies above the crowd and drops a number of table tennis balls. The number on the ball corresponds to a prize. Use the information in the diagram to find the amount of time that the ball is in the air. Alright, what an odd problem. So, use the vertical motion model. This is the same equation that we have been using for, 1.5 chapters now, so hopefully you have it written down somewhere. We are mapping the height of the ball in terms of time t. So, here's our vertical motion model. If you don't have this written down, it should be written down. You should have it memorized. For the record, I'm not sure that I've actually mentioned this in the past. That negative 16, what that negative 16 is, that's gravity. Alright, it is negative because gravity pulls you back down onto Earth. So that is, the force of gravity. And so it's negative 16. If you are, this isn't, typically the height is measured in feet when we're using the negative 16. If we're using meters, it's just a little bit different number that we're going to use. So, the ball is being dropped, which means that the velocity or the speed that, it's initially projected at is 0. And to figure out where the 45 comes from, I would go ahead and look back at the problem. And I would get that 45 from the height of the blimp here in the picture. Alright, so that is where our 45 comes from. That's your starting height. And determine velocity. When an object is dropped, it has an initial velocity of 0 feet per second. Alright, that's something that we've mentioned previously as well in different sections. So, step 2. Find the amount of time the ball is in the air by substituting in 17 for h. So 17 is the height I want it to hit my hand, and you can figure that out by looking at the picture again. There's me. I want it to hit my hand, and I'm at 17 feet above the floor. Alright, so going back to it, I want to substitute that 17 in for h, and I do so here. And then I don't have a regular t term, I just have a t squared. So let's go ahead and isolate that t squared. Alright, by subtracting 45 from both sides. Divide by negative 16. When I do that, the other side turns positive. Alright, which is going to result in 2 solutions for me. There is a plus or minus. They didn't include the minus here. They actually said take the positive square root. Why don't they include the minus? Well, I can't have negative time. So they just go ahead and rule that out in the first step. So when they take the square root, you need to make sure that on your calculator, if something's not going right, you could slap some parentheses underneath that square root, and that might help you out. So time approximately comes out to 1.32. Interpreting the solution, just like I said, because of time can't be negative, we ignore the negative square root. Alright, so the answer, 1.32 seconds. So here's a couple of guided practice problems. Please feel free to pause the video, check them out, see if your solutions match. Remember to work from the inside out. Alright, if you guys have any questions, always feel free to reach out, take advantage of those office hours. I look forward to hearing from you guys. I am pretty sure this content is going on your absolute last test, so finish out the semester well and make sure you understand it. So take charge and ask those questions. Alright, I look forward to hearing from you.